Hello students, welcome to our channel. In previous class we learned about quicksort algorithm. In this class we are going to analyze that quicksort algorithm. For any algorithm we consider three cases. One is worst case, average case, and best case. For quicksort, the time complexity in worst case is big O of n square. For average case, it is big O of n log n. For best case, it is big O of n log n. In this class, we are going to know how the worst case time complexity is big O of n square. So, how the average case is big O of n log n, and how the best case is big O of n log n. Okay. So, first we see worst case analysis. So, what is worst case analysis? If you give the input in ascending order. So, for example, I give the input like this 5, 15, 23, 25, 35, 48 and 56. Now, so what is the quicksort algorithm? We are going to select one element now. So, this is the element P. So, pivot element. Now, after partition, all the less than elements are left side to the pivot element, all the greater elements are right side of the pivot element. Now, if you try to apply the quicksort here, now how many elements? 1, 2, 3, 4, 5, 6, 7. 7 elements are there. This is the n, 7. Now, if you apply the quicksort, 5 is the partitioning element, that is a pivot element. There is no left here. The remaining elements are n minus 1. Okay, this is the partition. There is no left partition. There is only right partition. Now again, so n minus 1 means 6 here. So this 6 is divided as 0 and the 15 is partition pivot element and the remaining numbers are n minus 1, that is 5. In next iteration 0, this is 23, the remaining numbers are 4. All the right side are greater than 23. In next iteration, this is 0, 25 and here remaining numbers 3. Next 0, 35, the remaining numbers are 2. Next iteration again 0, 48 and the remaining number is 1. Okay, in next iteration it is 0, 56, 0. Okay, so now if you observe that here I am taking n value and all the numbers are in ascending order, then the quicksort partitioning is 0, pivot element and n minus 1. In next iteration again 0, pivot element, n minus 2. Next one 0, pivot element, n minus 3 and so on. Okay. Now, this is the worst case. That means, if you give the elements are in the sorted order, here the elements are in the sorted order. Now, if you are trying to partition, then also there is no left partition. Now, so for this, what is the time complexity? Here, so T of n equals to 1 if n equals to 1. That means there is only one element, then the time complexity T of n is constant, that is 1. Now, T of n equals to, if n greater than 1, then what is the T of n here? T of n minus 1 plus Cn. So T of n minus 1 means, if you observe that here the time complexity for this 7 is T of n minus 1, that is the remaining numbers 6. So that means that here in next iteration there is no left side, only we have only right side. So it is the time complexity T of n equals to T of n minus 1 plus Cn. Now what is T of n minus 1? Substitute. T of n minus 1 equals to n plus, you are going to substitute n minus 1, n minus 1 minus 1, it is n minus 2 plus C of n minus 1. Okay, what is T of n minus 2? Again substitute T of n minus 3 plus C of n minus 2. Now we repeat this loop until this t term become as 1 here. We know the T of 1 equals to 1 here. So this is the T of 1, here n equals to 1. So T of 1 equals to 1. Now we make this term as a 1. This is the T of 1. Now if it is T of 1, then it is T of 2. So T of 1 plus C of 2 here. Okay. Now we add all these equations, adding up all the equations. So now what is T of n? T of n equals to T of n minus 1 plus n, that equals to T of n minus 2 plus n minus 1 plus n, that equals to T of n minus 3 plus n minus 2 plus n minus 1 plus n. So now we get 3n here, 3n, 1, 2, 3. So 3n minus 0 plus 1 plus 2 plus T of n minus 3. So how we get this? 3n's. Okay, 3n minus, that we express as 0 plus terms. Then replace the 3 with k. K n minus 0 plus 1 plus 2 plus up to k plus T of n minus k, that equals to, so this is sum of n natural numbers. So kn minus k into k minus 1 by 2 plus T of n minus k. We repeat this until this term become as 1 here. When it become as 1, now n minus k equals to 1. Now what is k? K equals to n minus 1. Okay, k equals to n minus 1. Now substitute n minus 1 in the place of k. So we get n minus 1 into n minus n minus 1 n minus 1 minus 1 by 2 plus T of 1, that equals to n square minus n minus n minus 1 whole square n minus 2 by 2 plus T of 1 equals to 1. If the n value equals to 1, the T of 1 equals to 1 here. So in these all the terms, when we calculate the time complexity, always we consider the highest value. Here we have 4 terms, n square, n minus 1 whole square, n minus 2 by 2 and plus 1. So this is the constant, so ignore. And in these 3 values, we consider the highest value. What is the highest value? N square. So the time complexity in worst case for quick sort is big O of n square. Okay. So next case is best case analysis. Best case analysis. So what is the worst case analysis? If we give the elements in sorted order, so that we call as worst case. Now what is the best case? The best case is nothing but array, the given array is partitioned as a middle number. Okay, that means the pivot evenly divided the array into the n into n by 2, n by 2. Okay, this is the best case. The worst case is the array is partitioned as 0 and minus 1. That is the worst case. The best case is the n is divided into n by 2, n by 2. Okay, so now we see the best case analysis. So now what is T of n? T of n equals to 1 if n equals to 1. In all other cases, the n is divided into n by 2. N by 2. How many parts? 2 parts. So it is 2t n by 2 plus n if n greater than 1 here. Okay, I hope you all are understand what is the best case analysis. The array is partitioned into equal parts and partition into n by 2, n by 2. N is divided into n by 2, n by 2. Next, n by 2 is divided as n by 4, n by 4. Next, n by 4 divided as n by 8, n by 8. So this is the best case in quicksort. So what is T of n? T of n equals to 2t n by 2 plus cn. Okay, so what is T of n by 2? What is T of n by 2? Substitute. If we substitute, we get 2t n by 4 plus n by 2. Okay, c is a constant. Now what is T of n by 4? T of n by 4 means if we substitute, we get 2t n by 8 plus n by 4. Okay, substitute these values in T of n. What is T of n? So 2t n by 2 plus cn. So we got, so T of n equals to 2 into, in the place of T of n by 2, we write this equation. So it is 2t n by 4 plus n by 2 plus n. Okay, now what is 2t n by 4 here? So this is the 2t n by 4. So again you write 2 into 2, 4, that we write as 2 square t n by 4 plus 2 cancel n plus n. So this we express as 2n, n plus n, 2n. Okay, so next, in the place of t n by 4, we are going to substitute 2t n by 8 plus n by 4 here. So 2 square 2t n by 8 plus n by 4 plus 2n. Okay, now what is the next term? Next term is 2 cube t n by 8 plus 3n. So this is the next term. Okay, now we substitute the constant with k value. Here 2, next one is 3. So the next term is 2 power k t n by, so this we express as 2 power 3. So here also 2 power k plus kn. Okay, now we repeat this loop until this become as 1. That means n by 2 power k equals to 1. Now n equals to 2 power k. What is k? K equals to log n. K equals to log n. Now you substitute here 2 power k t. So what is 2 power k? N. So n by n plus kn. Now 2 power k means n. You write n. N by n means 1. T power 1 means 1 plus, what is k? Log n into n. So k is log n. So log n into n. So that equals to n plus log n into n. Here we have two terms. One is n, another one is log n into n. In these two terms, the highest value is n log n. So we consider n log n. Now, so this is the best case analysis for quicksort. So the time complexity for best case analysis is big O of n log n. So now we see average case analysis. Average case analysis. Okay. In worst case, n is divided as 0, p, n minus 1. That means T of n equals to T of n minus 1 plus c. In best case, n is divided as n by 2, n by 2. So we write T of n equals to 2t n by 2 plus c. Okay. In average case, so what is the average case? Maybe it partition the array not equally. That means, for example, if the elements are 10, 5, 8, 35, 46, 96. Now this 10 is placed at 8, 5, 10, 46, 35, 96. Let us assume like this. Now this is the pivot value. Now this divide the array into, so here 3 elements, here 2 elements. Okay, that means here I equals to 3. Here the partition place is index is 3. So the left side is 3 element, the remaining are n minus I. So what is n here? 1, 2, 3, 4, 5, 6. 6 minus I, 3 here. The remaining elements are 3 here. Okay. So now for average, we will consider random element as a pivot. Here in our case, we consider the 10 as a pivot element. So here the T of n equals to T of I plus T of n minus I plus Cn. Okay, let us assume this is the equation 1. I hope you all are understand how we get this equation. How? Here I equals to 3. Now the time complexity of 3 plus the time complexity of the remaining numbers 6. 6 minus 3, so T of 3. Now if we combine these two terms, then we get the final time complexity T of n. Okay. Now so let us assume, so this is the equation 1. Now so we assume each sizes of the partition are equally the partition sides. So maybe sometimes 6, 4, sometimes 10, 15. So we assume that partition size as 1 by n here, 1 by n. Okay. So now here we are going to find T of n in terms of T of I plus T of n minus I. So first we find, so T of I, the expected value of T of I. So we express as E means expected value of T of I equals to 1 by n sigma j equals to 0 to n minus 1 T of j. Okay, this is the one term. For T of n we are going to find T of I and T of I minus n. So the first term is T of I equals to the expected value is, it is equally partitioned. So we consider 1 by n, sigma j equals to 0 to n minus 1, T of j is first term, and the second term is n minus 1. So expected value for T of n minus I, that equals to same 1 by n sigma j equals to 0 to n minus 1 T of j. That's it. This is the equation 3. Now so what is the T of n? T of n equals to T of I plus T of n minus I plus Cn. So add these two equations. So T of n equals to, if we add, we get the 2 by n sigma j equals to 0 to n minus 1. So T of j plus Cn. Okay. Now this is the term. So T of n equals to 2 by n sigma j equals to 0 to n minus 1 T of j plus Cn. So now multiplying both sides with n. So now n into t of n equals to, so n into n means here n cancel, so we get the 2 sigma j equals to 0 to n minus 1 t of j plus n into n cn square. Okay. Now, so this is the equation 4. Now, put n equals to n minus 1. In the place of n, we are going to substitute n minus 1. Okay, what we get? In the place of n minus 1 t of n minus 1 equals to 2 sigma j equals to 0 to n minus 1 minus 1. So, it is n minus 2 t of j plus c into the place of n we write n minus 1. This is the equation 5. Now, subtract 4 minus 5. Subtract these two equations 4 and 5. So, we get, so n t of n minus n minus 1 t of n minus 1 equals to 2t n minus 1 plus cn square minus c n minus 1 whole square. Okay. Now, n into t of n minus n minus 1 t of n minus 1 equals to 2t n minus 1 plus, so this is the cn square. Here also we are getting in the place of c n minus whole square c n square minus cn square minus c plus 2cn. So, cn square is cancel. The remaining one is minus c plus 2cn. Now, n into t of n minus n minus 1 t of n minus 1 equals to 2t n minus 1 plus 2cn minus c. Okay. So, next n t of n equals to, here, so this is the minus n minus 1 t of n minus 1, this goes to RHS. So, it becomes n t of n equals to n minus 1 t of n minus 1 plus 2t n minus 1 plus 2cn minus c. Okay. So, t of n minus 1 common here. So, n t of n equals to t n minus 1 2 plus n minus 1 plus 2cn minus c. Okay, here, so t of n minus 1 is common. Okay. Now, it becomes 2 plus n minus 1. So, n t of n equals to t of n minus 1. So, plus 2 minus 1, it becomes n plus 1 plus 2cn minus c. So, this is the c constant, ignore. So, it is n t of n equals to t of n minus 1 n plus 1 plus 2cn. Now, so divide the both sides by n into n minus 1. Divide both sides by n into n plus 1. Okay. So, now what we get is that t of n by n plus 1 equals to t of n minus 1 by n plus 2c by n plus 1. Okay, here, so n into t of n, so divide the both sides by n plus 1. So, n plus 1 into n, so n cancel, we get t of n by n plus 1. Here t of n minus 1 n plus 1 by n into n plus 1, n plus 1 cancel. So, we get t of n minus 1 by n. So, 2cn by n into n plus 1, n cancel. So, we get 2c n plus 1. Okay. Let us assume this is the equation 6. Now, put n equals to n minus 1 in equation 6. In the place of n we are going to write n minus 1. So, it becomes T of n minus 1, n minus 1 plus n means n, that equals to T of n minus 2 by n plus n minus 1 plus 2c by n. Okay. In the place of n we are going to take n minus 1. Now, again put n minus 2 in again put n equals to n minus 2 in equation 6. Now, n minus 2 means T of n minus 2 by n minus 2 plus 1 n minus 1, that equals to T of n minus 3 by n minus 2 plus 2c by n minus 1. So, what is the last term here? We repeat this until this term becomes as 1 here. So, when it becomes 1, T of 1 by, so n minus 3, here it is 3, here we get the 2. So, n minus 2, that means 1 value increment. So, it is 2 plus 2c, it starts from n minus 1 plus 1 by n plus next one is n plus 1 and so on. So, this we express as T of n by n plus 1. Now, so this series we express as log n plus c1. Okay, so this series summation we express as log n plus c1. So, T of n by n plus 1 equals to T of 1 by 2 plus 2c log n plus c1. Okay. Now, we write T of n by n plus 1 equals to T of 1 by 2 plus 2c log n plus 2c c1. So, now in this, these two are the constants. So, we ignore. So, T of n by n plus 1 equals to 2c log n. T of n equals to n plus 1 into 2c log n. So, this we express as 2cn log n plus 2c log n. Okay. In these two terms, so this is the constant, so we write as log n. Here also 2c constant, so n log n. In these two terms, always we consider highest term. So, n log n, if we compare, the maximum is n log n. So, we consider n log n. Okay. So, this is the average case analysis of quicksort, that is big O of n log n. You remember the best case analysis for quicksort is big O of n log n. For average case it is big O of n log n. For worst case, for quicksort it is big O of n square. Okay, remember this.